So we've got some example problems to go along with all the tangents and secants and their properties and what do we do when they intersect. So let's get right in. We're going to go through the thought process on each and every one of these. So find the value of x if RHS equals 3x plus 15. Well, I know that tangent lines that meet the radius are going to meet at a 90-degree angle, so I can say that 3x plus 15 is going to equal 90 degrees. And all I need to do here is solve this down. So I want to get 3x by itself. So I'm going to subtract 15 from both sides. 3x equals 90 minus 15, 75. Then I can divide both sides by 3. X equals 75 divided by 3, 25. Okay? Down below, find the perimeter of a quadrilateral KOST if all of these are tangent to the circle. So they're all tangent, which means each one of these points is just a singular point on the circle, but it also means that certain pieces are going to be congruent to each other by that property of our tangent lines. Okay, so let's start with OR. OR, they tell us, is 13, but OR meets OA out here at point O, so these two pieces are going to be congruent. And if OA, that had a single tick mark on it, is 13, then KA is also 13. And because KA and KC are tangent lines that meet at point K, I know that KC is also 13. So just by giving that one piece of information, OR, I can determine those four line segments. I can do the same thing with RS. So RS is going to be 12. So I know that CT is also 12 because of those double lines. And then I know that BRS and BS both meet outside the circle at that point, just like BT and CT. So all those points are going to be congruent to each other. So if I add all these up, because remember, I'm trying to find the perimeter, so I've got to add up all of these. So I take 12 plus 12 plus 12 plus 12, and I'm going to add that to 13 plus 13 plus 13 plus 13, and that is all going to equal, I can do this two different ways, 4 times 12, because I have 4 12s, plus 4 times 13 will give me 100, or I can do it the long way, 12 plus 12 plus 12 plus 12 plus 13 plus 13 plus 13 plus 13. Either way, our perimeter, not 110, is going to be 100. Over here, PS is tangent to circle M. We're looking for the measure of angle MPS, so this is what I'm looking for. But because we know that tangent lines meet the radius at 90 degrees, I have all of my angles in my triangle. One of them happens to be X, one of them is a 90-degree angle, and one of them is 61. That's the given information, and I know that triangles all add up, all their angles add up to equal 180 degrees. So I can combine like terms. 90 plus 61 equals 151. So x plus 151 equals 180. I can subtract 151 because I want to get x by itself from both sides. 180 minus 151. 180 minus 151 equals 29. X equals 29 degrees. Down here, we've got another one of these perimeter questions. I'm going to assume they're all tangents. I didn't include that before, but I'm going to assume that they're all tangents. So now let's use our little bits of information about tangent lines. If RE is 21, then I know RS also is 21 because they are tangent lines that meet outside the circle. If DA equals 22, DA equals 22, and these two tick marks tell me that it is separated into two congruent pieces. So 22 divided by 2 is 11 and 11, which means DE is also 11 because it meets DH at point D. WA is also going to be 11 because it meets AH at point A. And then I can use KA, the idea that it is 30 going all the way across. If I take 11 away from that, so 30 minus 11, that's going to equal 19. So I can plug that in for this spot right here. And that's going to be congruent with KS because it meets at point K. So if I add up all these pieces, we've got 2 times 21 plus 2 times 19 plus, and I've got 4 11s. That's going to equal 124. So by adding all those up, we had our 2 19s, we had our 2 21s, and we had our 4 11s. They all add up to equal 124. My last one, we've got our parts, okay, our secant lines and our tangent lines. So we've got our external and internal pieces, our external pieces and our whole pieces. So X, this first one, X times X equals 4 times 4 plus 12. Working this down, I know that my x's are going to combine to be x squared. 4 plus 12 is 16, so I'm going to take care of this. That way I can just multiply 4 times 16 to get 64. Take the square root of both of these. X equals square root, so second x squared of 64. X equals 8. This one's going to be a little bit trickier. So we have our whole pieces. Remember, we're going to need to add those up. We've got our external pieces. I say that because it's easy to forget that. So let's pay attention. We've got 10 as our external piece. Our whole piece, we've got x minus 19, but we have to add 10 to it because that is a part of our whole piece. We have this entire length, okay? Equals, same thing, 9 times our whole piece is going to be, and I'm actually going to move this down a little bit to give myself a little bit more room, x minus 12, but I have to add 9 to it because, again, it's this whole piece. Can't forget any of it. So now I'm going to combine like terms inside of my parentheses. 10 parentheses x, negative 19 plus 10 is going to be negative 9 equals 9x, negative 12 plus 9 is going to be negative 3. Now I can go on ahead and distribute. 10x minus 90 equals 9x minus 27. I can get my x's on the same side. So 9x is my smallest x. I want to subtract that over, which means I need to add 90 to both sides. So I have x equaling negative 27 plus 90, 63.